Hi, science fans, Bill Nye here. Today, let's talk about computers, amazing machines that power our world. They're in your pocket as a phone, in your car, and even on your wrist as a smartwatch. It's hard to imagine life without them. Computers make things easier, faster, and more fun, from streaming shows to connecting with friends. But have you ever wondered how they work? Inside, circuits and code solve problems and process information. And now a new kind of computer is coming, quantum computing. It could change everything we know about technology. But first, let's explore how today's computers work and how they've shaped our world. Let's peek under the hood of a traditional computer. These machines are the backbone of our digital world, powering everything from your smartphone to the world's most advanced research labs. But how do they actually think and process information? Imagine billions of tiny light switches, transistors, each either on or off. These transistors are the fundamental building blocks of every computer, acting as the gatekeepers for electrical signals. When you press a key or click your mouse, you're triggering a cascade of these switches deep inside the machine. This is binary code, zeros and ones called bits. Each bit is a single piece of information, and by combining them in different ways, computers can represent numbers, letters, images, and even sound. It's a language of pure logic where every instruction is broken down into the simplest possible choices. Everything your computer does, photos, music, games, and even complex calculations, is built from these bits. Every app you use, every website you visit, and every file you save is ultimately just a long string of zeros and ones carefully arranged and interpreted by the computer. The CPU, or central processing unit, flips these switches at incredible speeds. Billions of times per second, it processes instructions, performs calculations, and moves data around, acting as the brain of your computer. Think of it like solving a maze. Step by step, a traditional computer tries one path at a time, checking each possibility in sequence. It's methodical and precise, but it can only follow one trail at a time, never jumping ahead or considering multiple routes simultaneously. For small problems, this is fast and reliable. Your computer can zip through simple tasks in the blink of an eye, making it perfect for everyday jobs like browsing the web or editing documents. But as problems get bigger, with billions or even trillions of possibilities, it can take years, even for supercomputers. Tasks like simulating the weather, cracking complex codes, or searching massive databases can push even the fastest machines to their limits. Traditional computers are champions of sequential tasks, but they struggle with problems that need many possibilities considered at once. When faced with overwhelming complexity, they slow down, forced to check each option one after another. This limitation is why scientists started dreaming of a new kind of computer. They wondered, could there be a way to break free from the step-by-step approach and tackle huge challenges more efficiently? What if we could solve huge problems by looking at all the options at once? Imagine being able to explore every path in a maze simultaneously instead of one by one. That's where quantum computing comes in. It promises to revolutionize the way we solve problems, opening doors to possibilities we could only dream of before. Let's see how it works and why it could change the future of technology forever. Welcome to the world of quantum mechanics, the science of the super small. Here, the rules are unlike anything we experience in our everyday lives. At this scale, particles can behave in ways that seem almost magical, defying our usual expectations and opening up a universe of new possibilities. Traditional computers use bits, which are like tiny switches that can be either on or off, 0 or 1. But quantum computers use something far more powerful, qubits. Qubits are the building blocks of quantum computing, and they can do things bits simply can't. Imagine a spinning coin. While it's spinning, it's both heads and tails at once. This strange state is called superposition, and it's one of the key features that makes quantum computers so unique. A qubit can be a 0, a 1, or both at the same time. This means that a single qubit can hold much more information than a regular bit, and when you combine many qubits, the possibilities grow exponentially. This lets quantum computers process many possibilities simultaneously. Instead of working through problems step by step, they can consider countless solutions all at once, making them incredibly powerful for certain tasks. Back to our maze, imagine trying to find the exit. A regular computer would try one path, then another and another. But a quantum computer can explore every path at once, dramatically speeding up the process and finding solutions that would take classical computers much longer. This parallel power means quantum computers can tackle problems that stump even the fastest classical computers. They're especially good at solving complex puzzles, optimizing huge systems, and simulating the behavior of molecules and materials. It's not just faster, it's a whole new way of computing. Quantum computers represent a leap forward, not just an upgrade, and they're set to transform fields from cryptography to medicine. Traditional computers work with definite states, zeros and ones. But quantum computers work with probabilities and possibilities, using the strange rules of quantum physics to their advantage. This difference lets them approach problems in a revolutionary way, opening doors to solutions we never thought possible before. It's like comparing a bicycle to an airplane. Both are transport, but they operate on different principles. Quantum computers aren't just faster, they're fundamentally different. As we continue, let's dive deeper into the superpowers of qubits and discover how they're set to change the world as we know it. Qubits have another trick: entanglement. When two qubits are entangled, they're linked. No matter how far apart, changing one instantly affects the other. This spooky action lets quantum computers create complex webs of information. As you add more qubits, the computer's power grows exponentially. Just a few hundred qubits could, in theory, process more possibilities than atoms in the universe. But there's a catch: qubits are fragile. The slightest disturbance, heat, vibration, or magnetic fields, can destroy their quantum state. That's why quantum computers need extreme cold and isolation. Building and operating them is one of the greatest engineering challenges today. But if we can harness their power, the possibilities are staggering. Quantum computers could solve problems that are impossible for classical machines. So what kinds of problems are we talking about? Quantum computers shine where classical computers struggle. In medicine, they can simulate molecules, something traditional computers can only approximate. This could speed up drug discovery and help design revolutionary new materials. In logistics, they can optimize routes for delivery trucks or supply chains, saving time and resources. In finance, they could model markets and manage risk with unprecedented accuracy. And in cybersecurity, quantum computers could break current encryption, forcing us to invent new quantum-proof security. These are just a few examples. Quantum computing could transform entire industries. But before that happens, there are some big hurdles to overcome. Let's look at the challenges. Quantum computers are powerful, but building them is incredibly tough. Qubits are delicate and lose their quantum properties easily. This is called decoherence. To protect them, quantum computers are kept at temperatures colder than outer space and shielded from interference. This makes them massive, expensive, and complex to operate. Error correction is another challenge. Quantum information can't be copied, so scientists use clever codes that require many physical qubits for each reliable one. Programming quantum computers is also a whole new ballgame, requiring a different way of thinking. Right now, only a handful of useful quantum algorithms exist. We're still in the early days, think room-sized computers in the 1950s, but progress is accelerating. The potential is huge, but there's a long road ahead. So how could quantum computing change your life? Quantum breakthroughs will eventually transform our world. In healthcare, we could see cures for diseases and personalized medicine tailored to your DNA. For climate change, quantum computers could help design better batteries, solar panels, and energy grids. In finance and logistics, they'll optimize systems, making goods cheaper and more efficient. Artificial intelligence will get smarter, leading to better diagnostics and new discoveries. You might never own a quantum computer, but you'll benefit from their power through the cloud. The solutions they unlock will become part of everyday life. Quantum computing could lift all boats, pushing humanity forward. Quantum computers won't replace your laptop or phone. Traditional computers are perfect for everyday tasks: emails, games, browsing. Quantum computers are specialized tools for the toughest problems. The future is a hybrid classical and quantum computers working together. Classical computers handle routine tasks. Quantum computers tackle the hard stuff. Scientists already use this partnership today. Classical computers control and interpret results from quantum processors. It's not a competition, it's teamwork. Together, they'll unlock discoveries neither could achieve alone. We've journeyed from simple on-off switches to the wild world of qubits. Traditional computers are our digital workhorses. Quantum computers are the pioneers of possibility. We're at the dawn of a new era, just like when the first computers appeared. The challenges are big, but so is the potential. Quantum technology will help us tackle disease, climate change, and more. It's a new way to understand the universe and solve humanity's toughest problems. Even if you're not a quantum physicist, knowing the basics helps you appreciate the future being built, one qubit at a time. Next time you flip a light switch, think of a bit, or maybe a spinning qubit. The future of computing is coming, and it's going to be quantifiably awesome. If this video sparked your curiosity, give it a like, share it with a fellow tech lover, and subscribe for more deep tech explained simply.